Good morning, children. This is your chemistry online class. So, this is the last topic in this unit number 8, physical and chemical equilibrium. Already, I explained the topic as the predicting the extent of reaction, predicting the direction of the reaction, and calculation of synthesis of ammonia and dissociation of PCl5. Okay. So, in the next topic is Leachate Principle. Okay. So, in the Leachate Principle, so you study master this definition. Okay. So, if a system at equilibrium condition, yes, a system at equilibrium condition. So it's the formation of hydrogen iodide in the equation equilibrium reaction. So in this hydrogen iodide equation is H2 gas, then I2 gas, then the equilibrium reaction to form 2 moles of hydrogen iodide gas. Okay, so this is a equilibrium reaction. Okay, this is one equilibrium reaction. So if a system at equilibrium is disturbed by moving the reaction condition. Okay, so it is disturbed. Okay, so this is equilibrium reaction is disturbed. So this moving by the reaction condition. So what is the effect of temperature, the effect of pressure, temperature and concentration and catalyst. So this is the moving the disturbance of the reaction. Disturbing the reaction. So you read the line. If a system at equilibrium is disturbed by holding the reaction condition, then the system is adjusting itself. If the system means is the equilibrium reaction is a system. Okay. So it is disturbed, then it is adjust itself the new condition or new condition to re-establish the equilibrium. To re-establish the equilibrium. Okay. So this is the simple example formation of hydrogen iodide. So in this Leachate principle, systems start at equilibrium. So the change and stress in the made of system at equilibrium. So it is changing concentration. Okay, so in this reaction, changing concentration, changing concentration, changing temperature, changing pressure, changing volume, and addition of catalyst. Catalyst. Okay. So first, the Leachate principle, a system start at equilibrium. So this is the equilibrium reaction. So in this equilibrium reaction is disturbed. It is disturbed by moving the reaction condition. So the condition is concentration, temperature, pressure, volume, and the catalyst. Okay. So then, so in this system, is adjusting itself. In the system, adjusting itself the new condition to re-establish the equilibrium. This is the Leachate principle. So in this Leachate principle, so there are 4 types: the effect of temperature, effect of pressure, and effect of concentration. The next we will study the rate of addition of catalyst reaction. So 4 types we will study in this topic, Leachate principle reaction. Okay. So next one. So in the Leachate principle, the system is response by shifting the reactant and product inside to restore the equilibrium reaction. So you see the another one example. You see the another one example. 2SO2 plus O to the form of 2SO3. Okay, 2SO3. So this is one. Another one equilibrium reaction. So this equilibrium reaction is disturbed in the conditions, it is disturbed in these conditions, then the system is adjusted itself in the conditions to re-establish the equilibrium reaction. To re-establish the equilibrium reaction. The next, so what is Leachate principle? So the Leachate principle is saying if a stress is applied to a reaction mixture at equilibrium, so the net reaction goes in the direction that releases the stress. Okay. So who discovered by the Leachate principle? Say Henry Louis Leachate. So the Henry Louis is discovered by Leachate principle. Okay. So next is the Leachate principle. In the short form of pressure, temperature and concentration. So next is the Leachate principle, the equilibrium reaction. So in this equilibrium reaction, two example reactions I will go. So one is H2 plus I2 to form of 2H8. Then 2 moles of SO2 then react with oxygen 2 moles of 2 moles of SO3. Okay, so this is the equilibrium reaction. So this is product and this is reactant. Okay. So in this product and the reactant, in the original equilibrium is the equilibrium reaction, is the equilibrium reaction. So is here favored reaction. So in the favored reaction, reactant to product. A reactant to product is a forward reaction. A reactant to forward. Reactant to product is a forward reaction. So reactant to product is a forward reaction. So in this forward reaction, reactant value decreases, then the product value increases. The reactant value decreases, then the product value is increases. Then the next step is the equilibrium reaction. Then the backward reaction. So the product to reactant. The product to reactant is a backward reaction. Backward reaction. So the reactant increases, then the product will be decreases. The reactant increases, the product will be decreases. So this is the Leachate principle of backward reaction and forward reaction in the equilibrium reaction. Okay. So what is the stress and change in this form of Leachate principle? So change in concentration, change in temperature, change in pressure and change in volume in the addition of catalyst reaction. Addition of catalyst. The next one. So the factors affecting the Leachate principle. The factors affecting the Leachate principle. So in the first topic, effect of concentration. The effect of concentration. So in this effect of concentration is the best example, ion salt. Okay. So in this ion salt, what is the ion formula? Fe. Okay, so Fe 3 plus SCN, okay, to give in the aqueous medium, in this aqueous medium, we have V3 plus 2SCN aqueous medium. The equilibrium reaction, in the equilibrium reaction to form complexes form. If to form a new complex is formed. So you have ESCN 2 in the aqueous medium solution. Okay, this is the effect of concentration reaction. So in this effect of concentration reaction, the thiocyanate, the SCN is a thiocyanate. So ion is a metal. So ion is reacted with the thiocyanate. Is a colorless. Is a colorless. So it is get in the equilibrium reaction to form a one complex is formed. The ion is dithiocyanate complex. So in this thiocyanate complex is a blood color. Blood color is formed. in the thiocyanate complex. So in this reaction, let us consider the equilibrium reaction is increasing the concentration of the reactant, increasing the concentration of the reactant and increasing the color of the complexes formed. So what is the reactant? So the reactant is ion and thiocyanate is a reactant. Okay? So you increase the reactant. You increase the reactant concentration. Okay. So increase the reactant concentration and increase the color of product. Okay, so first colorless solution to form of color, red color is formed. So increase the reactant concentration. So this is the equilibrium. The system starts at equilibrium. It will disturb by moving the condition. So the condition is concentration. Okay. So increase the reactant concentration. Okay. So in this disturb the reaction. So in this reaction is adjust itself. Adjust itself to the condition. Adjust itself to the condition. So the concentration, the effect of concentration condition. So next, increase the reactant favor the forward reaction. Increase the reactant favor the forward reaction. Forward reaction. Okay. So this is forward reaction and this is backward reaction. So the product favors in backward reaction. Okay. So the reactant favor in forward reaction. Then the product favor in backward reaction or reverse reaction. No. So this is the effect of concentration. Then, so in this forward reaction, decrease the reactant. In this forward reaction, decrease the reactant. And then the backward reaction is increase and decrease the reactant and product. Okay, so the forward reaction decrease the reactant. Then the backward reaction increase or decrease the reactant and product. Reactant or product. Reactant or product. So this is the concept of effect of concentration. So in this effect of concentration, the example is ion complex. Okay, ion complex. So the thiocyanate complex is formed. So the ion is reacted with thiocyanate to form a thiocyanate complex is formed. So in this colorless compound to form of blood red color is formed. So in this concentration, increase the reactant concentration and increase the color of the product. Increase the color of the product. In the reactant is favors the forward reaction and the product is favors the backward reaction. So in this forward reaction is decrease the reactant and then backward reaction is increase or decrease the reactant and product. Increase the reactant and product. Okay. So next, effect of temperature. Okay, what is the next topic? Effect of temperature. So on calculation, the effect of concentration, so on calculation. So the calculation, so all of you take your book, page number 16. So So the formation of hydrogen iodide is a given data value. So the concentration of hydrogen iodide value is 1 molar. Then hydrogen value is 0.2 molar. Then I2 value is 0.1 molar. So you write the Kc value. So what is the Kc? Kc is hydrogen iodide 2, then H2, then I2. Okay. So write the Kc value. Hydrogen iodide is 1 into 1. The next is hydrogen 0.2 into 0.1. Okay. So your Kc value is 50. Kc value is 50. Okay. So next the equilibrium was disturbed by adding the 0.1 molarity of iodine. Okay, so the iodine is disturbing the concentration of the reaction. So after sometimes the concentration of hydrogen iodide is found to be 1.092 molar. Okay. So you write the table the concentration at equilibrium. Then the disturbance of iodine 0.1. Then the concentration is immediately after the addition of iodine. So next all of you draw the table. So in this effect of concentration, the reaction of formation of hydrogen iodide. So in this concentration of equilibrium, the concentration of equilibrium in this reaction. So the reaction is H2 plus I2. The equilibrium reaction of 2 moles of hydrogen iodide is formed. So in this reaction, the concentration at equilibrium. So in this concentration at equilibrium, what is the H2 value? So in this H2 value is 0.2. H2 value is 0.2. Then I2 value is 0.1. Okay. So in this value, concentration at equilibrium, the reactant H2 value is 0.2, I2 value is 0.1. Okay. The next is the disturbance of iodine. The disturbance of iodine concentration. The disturbance of iodine concentration 0.1 molarity. 0.1 molarity. So the hydrogen value is 0.2 and already iodine concentration 0.1 plus addition of another 0.1 molarity means so the addition of 0.2 molarity is 0.2 molarity. So the formation of hydrogen iodide is 1. The formation of hydrogen iodide is 1. So 0.1 means 2 moles of hydrogen iodide is formed. So the 0.2 moles of addition of iodide means 1 mole of hydrogen iodide is formed. Okay. The next, the concentration immediately after the addition of iodine. After the addition of iodine. So in this value is minus x. Okay, minus x. This is minus x. Okay. So next to form of 2 moles of hydrogen iodide to form. So 2x. Okay. So next, change in concentration. So the change in concentration is so this value is 0.2, 0.2, 0.2, 0.21. So change in concentration is minus x, then 2x. So the new concentration. So the new concentration means 0.2 minus x, then 0.2 minus x, then 2x minus x. 0.2 minus x, 0.2 minus x. The next one, 1 minus 2x. So 1 minus 2x. So in the next step, so the concentration of hydrogen iodide. In the concentration of hydrogen iodide, the value, concentration of hydrogen iodide, the value is 1.092 molarity. In the concentration of hydrogen iodide, the value is 1.092 molarity. Okay. So next you write the 2x value. The hydrogen iodide is 1 minus 2x. The hydrogen iodide is 1 minus 2x. Q1 minus 2x. So in this 1 plus 2x value is 1.092 molarity. So in this 2x value is 0.092. 0.092 molarity. So this is the formation of hydrogen iodide value. So what is the x value? So the x value is equal to 0.046 molarity is the x value. Okay. The next you write the hydrogen and the iodine value. So what is the hydrogen value? So in this hydrogen H2 is equal to 0.2 into 0.2 minus x equal to 0.2 minus x value is 0.046. The next I2 0.2 minus x is 0.2 minus 0.046. So the value is same value. So what is the value? 0.154. 0.154. So this is the concentration, the effect of concentration. So first in the effect of concentration, change in the reactant concentration. So increasing the product and increasing the color of the complex. So in this calculation, the formation of hydrogen iodide. So this is your given value. So this is your Kc value. So next in this formula, the concentration at equilibrium to form the new concentration. So you finding the formation of hydrogen iodide, 1 mole of hydrogen iodide value. So in this hydrogen and iodine concentration value is 0.154. So next one graph is present. So the graph is representing the effect of concentration. So next is the Q value. Q value is the Kc formula value, hydrogen iodide concentration 2 divided by H2 and I2. So in this hydrogen iodide value is 1.092. 1.092. So you write 1.092 square divided by, so H2 value and I2 value. So what is the H2 value? 0.154 and I2 value 0.154. So 0.154 into 0.154. So the Q value answer is 50. Okay, so what is the Kc value? Kc value 50 and Q value 50. So K is equal to Q. It's the equilibrium reaction. K is equal to Q is the equilibrium reaction. So you draw the graph. So the graph is time and concentration. The time and concentration. So in this concentration, first the hydrogen value is 0.2. In the hydrogen value 0.2 the hydrogen value. The next one the iodine value is 0.1. The iodine value is 0.1. The next to disturb the concentration. The disturbing the concentration of iodine. The disturbing the concentration of iodine plus 0.1. So the plus 0.1. So in this plus 0.1, so the iodine. So H2 plus I2 iodine. Okay, so in this reaction to form in this followed by the reaction. So this, the product is hydrogen iodide is the product is formed. So in this hydrogen iodide product form in this equilibrium reaction. In this equilibrium reaction. So Q is equal to K. Q is equal to K is the equilibrium reaction. So in this reaction, the range is in this reaction, the range is 1.092. Then this range is 0.154. Okay, so this is the equilibrium reaction. So the effect of concentration, the formation of hydrogen iodide. Formation of hydrogen iodide. Then next effect of temperature. The next effect of pressure. So in this effect of pressure, is the main example equilibrium reaction is ammonia. The ammonia N2 plus 3H2 to form a 2 moles of ammonia. The 2 moles of ammonia in the effect of pressure reaction. So in this reaction, when the pressure on the system is increased, the volume is decreased. Okay, when the pressure on the system is increased, the volume is decreased proportionally. The system is shifting the equilibrium in a reaction. Equilibrium in a reaction. So if the product is increase the forward reaction. The product, so which is the product? So the product is increase the forward reaction. Product is increase the forward reaction. Okay. So the nitrogen is reacted with hydrogen to form 2 moles of ammonia is the equilibrium reaction. So in this equilibrium reaction, this is reactant and product. Okay. So when you apply the pressure, so the product is the forward reaction is increases. The forward reaction is increases. The next the backward reaction. The backward reaction product is decreases. The product decrease the backward reaction. Backward reaction. So this is the main reason of effect of pressure. The next one is the effect of temperature. So in this effect of temperature, the forward reaction and the backward reaction is increasing the temperature. Is the endothermic reaction. The next one, the effect of temperature. So in this forward reaction is endothermic reaction. So the endothermic reaction, it is increase the temperature. It is increase the temperature. The next backward reaction, exothermic reaction, decrease the temperature. Okay. So this is the effect of temperature and the effect of pressure. So the effect of pressure, the product is increase the forward reaction and the product is decrease the backward reaction. So the effect of temperature is the forward reaction is the endothermic reaction and it is increasing the temperature. Then the backward reaction is exothermic reaction. It is the exothermic reaction. This decreasing the temperature. Then the effect of catalyst. So in this catalyst, the addition of catalyst has no effect of equilibrium process. In the addition of catalyst, it is no effect, no effect in the equilibrium reaction, the equilibrium system. Okay. So in the effect, the addition of the catalyst is the increase the forward reaction and the backward reaction is equal. Increase the forward reaction and the backward reaction equally. So the effect of catalyst. In the effect of catalyst, increase the forward reaction and backward reaction is equally. Okay. So it is no changes in the equilibrium. It is no changes in the equilibrium reaction. So in the Leachate principle, so what is the Leachate principle? If your system is in equilibrium, it is disturbed in the conditions. So what is the conditions? Concentration, temperature, pressure, volume and catalyst. Okay. So in the system is disturbed, then the disturbing system is adjust itself and re-establish the equilibrium reaction. Is the Leachate principle. So the first one is the effect of concentration, then effect of pressure, effect of temperature, and the effect of catalyst is the Leachate principle. Okay. So now your homework. So after study what is Leachate principle and then the effect of temperature. What is Leachate principle and write a note on the effect of temperature. Okay, this is your homework. Okay, children. So if you write in your homework what is Leachate principle and write a note on effect on temperature. Thank you.